Okay, welcome to next session of our design pattern course. A little bit about myself again. So I'm running backend ready systems for already more than 10 years. So worked in high-load systems and I worked a lot with different softwares. So I've covered a lot of patterns in my life. Still not all of them because it's a very wide topic. And I hope that you can learn from my experience, and that's all about my career experience. So last week we discussed state pattern and proxy pattern. Anyone could share what they remember about state pattern? About the time. So state pattern telling us that we may use states for implementing different behaviors, not only just like string, like bunch of strings that's responsible for state. I actually had very interesting conversations with other people about state pattern, and it could be applied in data-oriented programming still, where like you want to restrict some specific behavior only for some specific states. So that's about state pattern, but mostly we covered state machine, which very helpful to design production products. Like you can also define life cycle of the product. That's where a state machine can be helpful. For proxy pattern, we discussed how many proxies we could find in the real world today, like load balancer proxies, like rate limiting, putting in front of application and help you again to manage the load, like caching. So we could put a proxy that's going to be the proxy to help to serve quicker responses when you use caches. And you could also notice that it's very similar to the creator pattern as well. And I would agree with that, because when you go to system design level, it's not much about designing them in exact order of class diagrams that you could do on low level when you design in code base. It's more about understanding the concepts behind the patterns. And we kind of decorating our applications today in system design level with different proxies. We can say like this. This is what I would say about this pattern. Okay, so today I'm going to share with you chain of responsibility. And it was one of the first ever patterns I was using to come up with better design for the application. Personally, I love this pattern because it helped me to design products, and not products, low-level design of organizing code base. So it was easier to navigate between different things. Now, design that we have in this in design patterns book is about the application where we have Gumball machine. You maybe remember Gumball machine from state pattern. And now they want to get all the mails about this machine, about how everyone plays with it, etc. And the CEO, who our most important client who wanted this game, now wants to have mails from everyone who actually using this game. And apparently, these mails could be really different to each other. And sometimes it's complaints. And sometimes it's customers that love game and still would like us to help them to basically like all complaints should go to legal departments and all requests for new machines should go to business development department. Yeah. So we want to build very smart filters for these emails whenever they come in from. That's the most idea for chain responsibility patterns. So when you think about where this pattern could apply, you have ongoing messages, ongoing traffic, ongoing requests, whenever it could be. In this example, it's email. And you want to handle this traffic of data that's coming and coming and coming again, but you want them by specific rules to go to different sources, like to different consumers. Yeah, to different consumers. It will be correct to say to different consumers. In our case, for this example, legal department, one consumer, and the business development department is another consumer. However, the stream of data is the same. Here, a stream of data, it's email. So they come in and come in and come in from all over the world. So now, we can say that some AI detections already in the place. So some emails go to spam and complaint request. We already have them marked, which is important. We don't need to analyze them and mark them manually. So now we're basically creating a few handlers that's going to handle our request. And they all implement interface handler that will be class diagram of chain responsibility pattern. So the idea is that whenever you get this traffic, it goes through different handlers. Let me see if I have, yeah, this is diagram that's very good. It's a very good way to explain how traffic goes from one handler to another handler. It's not the same as decorator pattern. So when you think about decorator pattern, you can imagine onion or I don't know. Yeah, onion is a good idea. So you have different layers where you decorate your application, where you decorate your main logic, etc. But here it's not an onion, so you don't have them wrapping one by one around. Here you have them as a chain. That's why like it's chain of responsibilities. Here, like you can think about, it's an analogy to remember this is like different beads that you put on necklace. So that's how you can remember this pattern. And this is the pattern that allow you to just build these few handlers for ongoing traffic. And every time when spam is getting email, they marked already with spam, so it doesn't go next. It doesn't go to fan handler. It may go next, but you can develop it a new way where it doesn't. So for example, spam handler just drop traffic and it doesn't go next. Then fan handler drop it to business development department. So because we think it's fans who requested new features. And again, like we actually don't have to give it next to complaint handler. So we just dropped it to business department and that's it. Then complaint handler, it go to legal department. And then we think like everything else go to new localization, new location. Yeah, of the end, you can always implement catch-all handler. Yeah, okay. Let's go to this example. No, I'm sharing the whole window, so that's fine. Chain of responsibilities. This very good example where it already implemented in real life. So basically, when you use, it's very common for frameworks to implement it in this way, where you actually use it for authentication and authorization. You may remember when we discussed about decorators that you could do a lot of things for authentication, authorization, validation, and caching. And here we think that implementing it is chain of responsibility, as many handlers can give you good example how to drop things when you don't need them. You can be confused because we discussed that it could be decoration. However, here we have it as chain of responsibilities. And if you look at class diagram, it will be different. It will be different. And here we can say you could do both when you implement authorization, authentication, and etc. You actually can do both. You can use it through chain of responsibility pattern, or you could use it as decorator pattern. It will be different result, and it will be different idea how to go through this pattern. It's an interesting business case, kind of real-time example where two patterns could be applied to solve the same problem. And the result will be a bit different in case like how exactly you do this. So when we did it for decorator pattern, we said like, okay, when we cache in result, we basically return result quite quickly, which is mean we kind of didn't go through any other things with the real result. When we said that we authorize the person, and if the person is not authorized for this API, we actually we basically drop request as well. And this is what the idea of chain responsibility is, that as soon as the first handler hit, you may drop the thing on the floor and then like do not go through another handlers. Yeah, so it's very like, if you remember the creator, then you can think like, okay, that's different pattern, but worldwide, it's the same problem with how exactly you organize your different layers before request and response. Could be implemented with two ideas in mind. First, decoration, and then chain of responsibility to basically drop data stream before it hits next handler, something like this. Very interesting exercise. If you by yourself use some frameworks that already do this authentication, authorization, caching, anything like, for example, if I talk about Java or Kotlin ecosystem, I would say Spring Boot, something that we use widely to boot up application, boot up server, Spring Boot server, and then accept request and response. If I talk about Python ecosystem, I believe that yes, there is a framework, I forgot the name, but there is also a very popular framework. So it's on the top of my head. And you can check how it's implemented in these frameworks, and you can find out like you can try to do this like a mental exercise. Oh, if this one is the creator pattern or its chain of responsibility patterns, which is like the difference will be how different handlers to get request and response, how they are constructed. So that will be interesting exercise to check to see like how it's implemented. If I come back to, yeah, this is the one. So the process of different kinds and requests that go in various ways and exact types of requests the exact types of requests and their sequences are unknown beforehand, which is mean you don't know yet if the person authorized or like if a mail should go to business development or whatever. Like it's like the traffic of data that may be marked somehow, but you don't know yet how exactly to handle this. This is what it say about. This is why it's say like unknown beforehand. Okay, I'm going to continue slideshow here. Also, need just a moment because I see that I got to give costs. Give it to the day here. Yeah. Good. Now, that's example, another one that could give you interesting idea where chain responsibility could be applied. That's from my career experience. So imagine we build an engine that have offers selling actually cars, trucks, motors, lorries, whatever. So basically, we have absolutely different services that handle data about them because I don't know, they have different formats. You need to show different information back. That's just different data storages, like different repositories. So now we could analyze offer by implementing a lot of if it's like this. This is a straightforward approach. Now, more and more requirements are coming up because here we say that we have car and BMV, and only in this case we're going to save data. So basically, we want to filter cars by being BMW, and we want to save only motors that are black. Now, when we want to basically create all these filters, we create them in filter method, and this filter will have the same things that we had as an if. Now, we build factory. We build factories that's given us a collection of filters, and this collection of filters will be exactly what we want. And yeah, example here is we may create it car like that was deleted in the past. So we create and deleting filters. So in this case, when we get something for deletion, it goes through filter to delete them. And now this is how data flow is going to run. So that's similar diagrams that it was for emails or for requests and response. This is data coming, and as soon as I hit car filter, and if they go to the filter, then like they may go to one another filter and go to the place where they should go. And if it's not, it goes to next filter. If it's not, it goes to next filter. And that's how we process our data. So this is another similar example when you have ongoing flow and you don't know yet what data you need to serve. You need to mark them somehow to check them. They already marked, but you need to filter them. And as soon as they go to specific way, then you do what it's needed for exactly this data. So that's small examples where it could apply it. And when you refactor like this, it's easier to support it because the filter itself could be quite complex. And you just rub the logic about filtering inside filter, and that's it. And you can build up to like, I don't know, 10, 20 filters, but because everyone is like different and can have complex logic under the hood, like you just wrap up them and you know what's going to happen when filters are passed by giving them exact place where this filter is going. So something like this. Yeah, another analogy is that's like this is kind of task. Oh, I built this image 2 years ago. I think now I would build it now. It will be much better. But yeah, I built this image 2 years ago, and yeah, that when you look at task management tool, you may think like Okay. Um, Service desk, for example, you may see that you also can apply chain of filters so that quicker goes to exact person or department that needs to surface request. Okay, any questions on chain of responsibility? Was it good? Now we learn to next pattern that's called mediator. If you go to example in the book, again, like all this example, you could just find in the book and go through them and check class diagrams, especially if you really like this pattern, you can go and dive deeper into this. So, now for this one, we are looking at house of the future. Now, we want to remain not far away from this if we have a lot of devices connected together through Wi-Fi. And yeah, I believe it's Wi-Fi. So it could be house of smart bulbs. I actually have smart bulbs. Smart bulbs, they use Wi-Fi and they connect it to your cloud account. That could be Amazon Alexa account. It could be Google Home account. What else you can have there? Today, definitely you can have different devices like check humidity, check temperature, etc. You also can connect them to your account. If you know any other important device, just share in chat if you use anything. And of course, devices like Amazon Alexa. So basically, you can build today smart house. And let's think about some software that you could use to basically connect all these devices together. So when we're looking at what clients could ask for, like, so Bob here is developed already software for smart house, and clients asking for new features like could we have somehow coffee machine is in this network, but I don't know yet coffee machine that work with it. Share with me model if you know. We want the features that say that there will be no coffee on weekend. We have like sprinklers, and they help us for gardening, but we don't want them 15 minutes before a shower scheduled. And shower, we need it because we need to heat water before shower. So yeah. Okay. That is the video. That's to make this session a bit more interactive. Let me think what it's going. Yeah, okay. I think you can see it well. Let me see the video. Yes. Yes, that's it, but I don't know how to translate, but it's just the music. So it doesn't, it's kind of doesn't matter. So it's not silent, but it's just music. So yeah, basically this is from series. I don't know if anyone watched this series. And this is what it reminded me, like how software for smart house who could look like to be really perfect. A bit interactive. Anyone watched this series? Anyone watched like any? Yeah, you have done. It's yeah, I love them actually because they're serious about very interesting topics about life and future and technologies. Yeah, and a lot of food for thought. Yeah, so this one there was because it's so hard to build smart house. That's and this series that basically put the person to manage this. Like only person actually can really to be really good at managing what another person wants personal assistant. Um, Now, let's go to this boring example where we just need to write the code base to do all of this and see if it's possible to do it much better if we use some pattern. So what's going to happen here? We have few devices. Let's say it's alarm, it's calendar, it's sprinkler, and it's a coffee pot. And we basically want them organized to go to listen to some events and to basically work on it like when some happening. Yeah, like so. Yeah. Um, when we look at this object diagram, it looks like kind of hard to keep track of like what rules we need to apply, especially when users come in this new feature. And here is going the pattern. So how pattern is going to solve this? Mediators say like, okay, I'm going to centralize everything that you're trying to do. I'm going to be the mediator who knows what to do on what event. And it looks a bit counterintuitive if we remember about publisher-subscriber pattern, because in publisher-subscriber, we just decouple them without any centralized actor. But that's something about having everything centralized. Why it's happening? Because patterns like you really may choose different way to do things, depends on the problem. Very good question. Is it called coordinator pattern? Good question. So here I'm looking at classic Go patterns, and that's names that 4 people come up to when they wrote book. So we can now think about, oh, that's different concepts. Because if you're asking about naming, I also discussing about more on different levels. So it's not necessary to be a Java developer to implement these patterns. Or you can think like where in life it's going to be implemented. That's why name is not as important. It's not about name, it's about the concept. And it's not about exact code base and exact class diagram. It's more about the concept. So let me see what else happened. Mediator patterns when it's hard to change some of the classes because they tightly coupled to a bunch of other classes. So basically, when we look at this diagram, they still couple together. And it's really reminds me like when you build a few microservices and you actually need to interact, like those microservices should interact. But normally we would solve it with message queue and just say like, oh, on different messages on different events, we're going to do different things. But we come to the same problem here on exact event. There should be a few different things. So that's becoming confusing still. And here mediator is actually going to coordinate, it's a good word, what is going to happen between different devices in our case. Yeah, now another one too. go with it. Again, it doesn't matter about actually, let me try. Maybe I know how to. No, there was a way actually to translate this. Let me try just in different way. So I'm going to do next. I'm going to stop showing here and start to show exact path with airplanes. Now I'm going to start.
Why do all the...
Yeah, and I think now you can have audio as well. Okay, now it's because I talk in here, it will be better. Hey, hope it's good. It's good fun.
Why do all the planes flying over the Atlantic choose this specific narrow path? Look, it's a really crazy bunch of planes, moving along an invisible highway in perfect order on parallel paths. But why is that? Well, firstly, this is the shortest way between the USA and Europe, and secondly, there's an actual highway in the sky called the jet stream. Jet stream is a powerful air current that moves from west to east. It saves fuel and makes flights shorter and less turbulent. That's why flights from the US to Europe are usually faster than in the opposite direction. But how do they avoid collisions, especially since radars don't work over the Atlantic? You see, it's all handled by the North Atlantic tracks. Since jet streams are constantly shifting, experts analyze a lot of data every day and literally create tracks for the planes. As planes approach these tracks, pilots request permission to enter them. Air traffic controllers, based on all the requests, optimally schedule the planes by setting speed, altitude, and distance, which makes flying so safe. Why do all the planes flying over the Atlantic choose...
Yeah, now we're coming back to this one. Okay, so that was a bit step away to think about coordinators, like good analogy for brains to memorize what was mediator pattern about. And if you don't know what you've learned from today's session, at least you've learned about traffic jets and why they use the same path. Like I found it when I was preparing the presentation and I was looking like, oh, what else I could bring as examples, like, and I hope you enjoy the format when you also have some interactive videos. I definitely didn't know when I found it about it, and yeah, now we learn that. Now let's look at design patterns for also more examples of mediator to understand where it's coming. So we may talk about how we create an application where we need to handle different things, a desktop application. And actually, I was thinking about it. And now in generative AI era, you may want much more to try to develop your own desktop application. So basically, you can go and check patterns that were popular 30 years ago, because today it's so easy to build your own dashboards, your own your own anything you want, even desktop applications. Like it's much easier today. So that's another way that it's important. I think mobile applications where like you have buttons, you have text fields and bulkhead. I've never worked as a mobile developer, so I only can guess, but I understand that that's also about interactions between objects. And yeah, like that's a good example where you can see that mediator pattern came in and taking the place. So here's a build it through dialog, and dialog manage all these different objects to interact with. basically dialogue, not with each other. Otherwise, like it will be too many events. It's a good example. Again, coordinating different airplanes. Now you know why. If we go and look at classic diagram, we see that we create an interface of mediator because it was very popular to create interface for anything whenever you want. Then exact implementation. You may omit interface mediator if you have only one mediator in your application. Like if you're sure that it will be one mediator forever, I think that's totally fine to not create interface for this. But next thing is actually understanding what components you have inside and say always exact reactions on them. So yeah, it's again, like to me this pattern goes a bit in comparison with putting the message queue and then still having the kind of understanding what to do depends on what. But for these exact cases, this pattern will serve much better. So one of the things that's quickly come into my mind is when you have a few servers on system design level, you also have some servers that manage them. If you ever worked with Kafka, you may heard about Zookeeper. Zookeeper is the one who Zookeeper is the one who basically designed to coordinate different services. Like you can build Zookeeper if you like just have a few services and you want them to be managed by some another server. And Zookeeper was popular in Kafka because it's basically if you install Kafka, you also install Zookeeper. That was a few years ago. Because you want Zookeeper to coordinate Kafka nodes, Kafka cluster. Like only recently they implemented Raft protocol to find consensus who exactly leading node, who is not, if one node is dying. And it's another long conversation. I'm not going to share more details here because Raft protocol is something very complex on system design level, and it's very unlikely you would ever have to implement this protocol. Zookeeper is the one who acts as mediator when you spin up few nodes of whenever you want, for example, of Kafka. Yeah, so basically that's it. Now, when we go to another examples, we may say, yeah, share this this now. We have order system and we want to have order processor, and we may have another component. And at the end of the day, we also have inventory manager who is going to update stocks. So basically, we can think about order system like the shop, big shop, yeah. And mediator pattern come in here and say like, I'm going to collect everything that's happening and notify sender this event of like what exactly happened. So here it acts like message queue if it's doing only notifying, but it's could be called mediator as well. That's why I say like, I don't think the name coordinator as well that important. What is important the concept to decouple things. So things are not coupled that much. Another example, orchestrator. I feel like that's a good example of mediator when we move into system design level. Anyone heard about orchestrators? Anyone worked with some orchestrator? Could you raise your hand? or if you at least heard about the concept. Okay, so orchestrator, one of the example in real world that you could Google and check, it's Google workflows. Basically, they allow you to design a few steps as, I don't know, some scripts, and design the plan, how you're going to execute the steps. And they going to execute those steps for you. So basically that looks to me like one of the example of complex design pattern to the system design that similar concept to mediator. Yeah. Okay. Any more questions on mediator? Okay. Bridge. What is it? So many things I invented. Now. So the thing that's bridge that basically tell you may want to have one more abstraction when you have when you design systems. And example from the book, let's say you have remote controls. Maybe you remember this from proxy pattern when we had Gamble machine, and now we wanted to do it remotely, and we've put their remote control. Now, let's do something completely new as remote control for TVs. Which is mean like you can tune channel whenever, like in any place where you want, without actually going and putting the same buttons on the same clicks. Yeah. Now, what is the problem? Remotes are going to change, and TV is going to change. Yeah, TVs are going to change. So we basically would have problem of changing every time our proxy, if we just put it as a proxy. And you already abstract your user interface, and you could have multiple implementations, like using strategy pattern. But still, you need to go to different abstractions. Still, you need even more flexibility. So here we're targeting kind of implementation and abstraction to have more and more flexibility. That's very complex pattern. Like, so basically, it says that when we have relationship between TV, that's going to be the one that you want to have remote control. We do more abstractions. So TV is one interface. An interface has two implementation, which is RSA and Sony. RCA, something like this. And remote control, it's in proxy, we just had the class, but now we're going to have an abstract class. And that's how we're going to use different implementation of this one. I will be honest, I've never came to this pattern in my career experience. So it's very hard for me to go to good examples from my experience. And one important note here, like it's important to learn about concepts that go behind these patterns, but it's totally okay if you would never ever even met the pattern in your life. I want you to take it away as well. So the main idea of this pattern is to use composition over inheritance, because that they instead of implementing TV, that could bound them this interface like on and off. That's how we would do in proxy, if I'm correct. We're going to have TV as a field, not implementate the metaconstant, and that's it. And the idea to use composition over inheritance, it's something like you can use this idea in any language. Every time when you think you want to implement something, you can just use this one as like a field instead of providing different permutations. Like you always can have it as a field. That's the main idea, because you may say like, oh, maybe everything will change soon. Okay, let's check what Guru Patterns is talking about, is telling us about branch pattern, and that's, yeah, let me go to this tab. So, example that they're sharing, it's a bit different concept, because here they say, let's think about different shapes and different colors. And if you try to implement objects based on shape and colors, we may end with many, many different objects, like too many services in our system. And to mitigate this problem, we may use this one, which is composition over inheritance. This is exactly the one, because we say that basically every shape may have color as a parameter, as a characteristic of the system. So the same we said with the remote control, it has to be as its parameter. And when next we need to implement the figures, we still would have them like 4 different objects. However, the problem that we're going to solve, that every time when we have changes, they mitigate it between different different actors. Like what is going to say that now if we have changes in shape, then only shape is responsible for these changes. And when we have changes in colors, only colors will serve these changes. But like it will be easier for you to serve changes, because you will not touch, instead of changing red colored square, blue circle, and blue square, instead of change each of them, you would change only circle and square with new changes. For example, I don't know, you need new fields. And for colors, you would change separately only red and blue colors. So at the end, if you have, yes, you would have, at the end, when you have one more shape and one more color, you would have 6 different objects here. But here you have, no, not 6, even more. You would have 8 different combinations, which is mean you would have to change 8 objects if changes are coming. But if you go this way, you will have only 6 different things, which is still less changes. And the only thing to add, changes are inevitable. Yes, and that's the idea, to basically decouple things to have less changes. Okay, that has good examples on system design level. That may mean that you decouple. Like here we have a lot of things that couple together, and here they are decoupled. On system design level, when you design service, you may one day say, you know what, data that's in this service and data this data could go to another service. And we always will go and get them from another service. This because when all these changes are coming, instead of changing one service, we would change two different services. That's a good technology, and I hope it helps to understand the idea behind kind of bridge pattern, but it could go as decoupling, as simple decoupling of big services to microservices. Yeah, something like this. Okay. Now let's go back and every time when you check group patterns website, you can also check what could be different relations between patterns as well. Okay, that's one of the most known counterintuitive patterns as well, is bridge pattern. Any questions so far? Okay, I think I have, no, I don't have. Yeah. So before I go to momentum, yeah. Oh, good question. Why is not adapter pattern? Because in adapter pattern, you do a bit different thing. Yeah, in adapter pattern, you do different things. You have different interfaces that you're facing. Example from real world, we have a lot of formats for serializations. Today we have our serialization, we have protobuf serialization, we have Pojo, plain Java models, and yeah, thank you. And we have very old protocol to exchange messages, so APT services. That was the highest way, but that's the oldest and one of the first amazing protocols to exchange messages in XML format. And you may face that you have integration. Oh, REST HTTP, I didn't say REST HTTP as a protocol to exchange these messages as well. And SOAP is different protocol to exchange messages in XML format as well. So you will face a situation where you have, thank you so much, where you have few services. So you have everything in one format, but now you need to integrate this vendor, very old one, with this SOAP protocol. And here you would use adapter pattern because you need to adapt your system to absolutely different API. However, you don't need to do anything different for this. Under the hood, you have the same logic. So instead of building different logic to work with this API, you build the layers that adapt this API with this vendor. Oh, yeah, okay. Hope to see you again. Those who's leaving. Yeah, so that's the difference for adapter pattern. Is it help? Does it help? So the problem a little bit different to whenever that's shared here. Like we don't, here in bridge pattern, we don't need to adapt anything. We want to decouple things because we want to decouple them and we want to build bridge between different services, for example. But in adapter pattern, we may build the whole new service that's going to adapt a few different APIs from, I don't know, 5 different vendors. That will be our adapter. They will put it in unified format, like, I don't know, XML, SOAP services, HTTP REST protocol, and then we will adapt them to our internal proto-gRPC API. And this proto-gRPC will go to next our services. And that will be what our adapter is going to do. And that's it. Does it help now for Thelma? How do you send a message? if you understand now the difference between them. Yeah, thank you. Good. Now we'll have a short break for the video, and I know that it's going to.
So Dan.
So
Do we have everything we need for this meeting?
Yeah.
It's all right here, sir.
Is your data backup as reliable as it should be?
Don't worry, sir. He told me everything.
Ours is. Brightstore storage software from.
So that was advertising. you can avoid it again. So basically, what has happened? Like he asked if we have everything important for meeting, and his colleague said it's all in the head, and then he failed. Like the node with data failed, and the next. His colleague told him like, okay, you have no worries. I remember everything in my head as well. And then like he slipped and like data lost. And this guy sitting there and he doesn't know where to start even because all data lost. So that's a bit hook before we go for memento pattern. Oh, sorry. Let me share my tab again with memento. So yeah, I hope it was a good break after this bridge pattern. Okay. Basically, the scenario in book, we build the game, and apparently we've decided that we forgot to save the state of the game. So as soon as people they go to first level, second level, third level, but if the character dead, then they have to start the game from first level, even if they, I don't know, 15 levels, they 15 levels. And it's very, very complaints of our customers, gamers who play our game. Like, it's amazing, but could you please save the state? So basically, Memento is about saving the state. I think if we go to group patterns, I also love this idea about Memento. The problem is going to happen if you build editor, because if you want to change a lot of text, etc., then you want to cancel this and you want to come back to previous state instead of starting this document again. That's another example. Now, they give this example here, and I know there are not too many Java developers, so I'm going to share with you what's exactly going to happen if you push object in memory in the map like this. You may go with out of memory error. So build that because you don't have to put them in the map. You need to put them in repository in database. Do not store snapshots of state in memory in map. Store them in repositories. And if you think about repositories and databases, that's basically what this concept is doing. Today, it's very important, and every database implemented that has a hood, they build a bunch of snapshots for you. So when database crashed or something crashed, a network crashed, they still have a few snapshots before they goes to basically to hardware. So they can recover from these snapshots. There are also good things like write ahead log. And this is how we, like, when you build application and you save data to database, it's not going immediately to database. Instead of it will go to snapshots, and it will asynchronously go to hardware, to hard disk, because otherwise it would be much slower if it will be immediately. This is one of the things that you can memorize about Memento as a pattern. And another idea of Git snapshots. That's also snapshots. That if you work with Git, or that's today's most popular version control system, they actually build a lot of snapshots for you under the hood as well. So that's where this Memento pattern implemented today. Okay, we have run a little bit out of time. So I want to thank anyone who ended and lasted here. Was the end of the session. I hope you enjoyed it today, and I'm going to stop recording now. Thank you so much.